Hello and welcome to this video walkthrough on performing simple linear regression for stock using scikit-learn. In this Jupyter notebook, we will be importing necessary libraries, downloading stock data, preprocessing the data, splitting it into training and testing sets, fitting a linear regression model, calculating the model's score and mean squared error, and predicting the next day's stock price. Let's get started. Welcome back. In this cell, we have a markdown heading that tells us we will be performing simple linear regression for stock using scikit-learn. This means we will be using scikit-learn, a popular Python library for machine learning, to create a linear regression model that can predict stock prices. We haven't written any code yet, but in the next cell, we will be importing necessary libraries, downloading stock data, preprocessing the data, splitting it into training and testing sets, fitting a linear regression model, calculating the model's score and mean squared error, and predicting the next day's stock price. Stay tuned for the next cell where we will start writing some code. Welcome back. In this cell, we are importing necessary libraries and setting up our environment for performing simple linear regression for stock using scikit-learn. We are importing pandas, NumPy, matplotlib, math, Seaborn, and fix_yahoo_finance libraries. These libraries will help us with data manipulation, visualization, and downloading stock data from Yahoo Finance. We are also using the magic command %matplotlib inline to display our plots inline in the Jupyter notebook. Lastly, we are importing and setting up fix_yahoo_finance library to download stock data. We will be using this library in the next cell to download stock data for Apple, AAPL, from January 1, 2016 to January 1, 2018. Stay tuned for the next cell where we will start downloading and preprocessing the stock data. Welcome back. In this cell, we are downloading stock data for Apple, AAPL, from January 1, 2016 to January 1, 2018 using the if.download function from the fix_yahoo_finance library. We are storing this data in a variable called data. We then use the data.head function to display the first 5 rows of the downloaded data. This will show us the opening, high, low, and closing prices of the stock, as well as the adjusted close price and volume for each day. In the next cell, we will be resetting the index of this data and storing it in a new variable called df. Stay tuned for the next cell where we will continue preprocessing the data. In this cell, we are resetting the index of our stock data and storing it in a new variable called df. This will help us manipulate and analyze the data more easily. We then use the df.head function to display the first 5 rows of the updated data. In the next cell, we will be dropping the date and close columns from df and storing the remaining columns in a variable called x, and storing the adjective close column in a variable called y. In this cell, we are creating 2 new variables called x and y. We are using the drop function to remove the date and close columns from our stock data, which is stored in the df variable. We then assign the remaining columns to x. Additionally, we are storing the adjective close column in a variable called y. This will help us separate the independent variables from the dependent variable, which is what we want to predict. In the next cell, we will be converting df into a matrix using the as_matrix function. In this cell, we are converting our updated stock data, which is stored in the df variable, into a matrix using the as_matrix function. This will help us perform linear regression on the data. In the next cell, we will be splitting the data into training and testing sets using the train_test_split function from the scikit-learn library. In this cell, we are using the train_test_split function from the scikit-learn library to split our data into training and testing sets. We are assigning the training and testing sets to 4 new variables, x_train, x_test, y_train, and y_test. The test_size parameter is set to 0.25, which means that 25% of the data will be used for testing and 75% will be used for training. The random_state parameter is set to 0, which ensures that the same random split is generated each time the code is run. In the next cell, we will be creating a linear regression model using the linear regression function from the scikit-learn library and fitting it to our training data. In this cell, we create a linear regression model using the scikit-learn library. We import the linear regression function from the sklearn.linear_model module and create an instance of the model called regression_model. We then fit the model to our training data, which we previously split into x_train and y_train using the train_test_split function. This will allow us to make predictions on our test data later on. In the next cell, we will print out the intercept for our model. In this cell, we retrieve the intercept for our linear regression model. We do this by accessing the intercept_attribute of our regression_model instance and storing it in a variable called intercept. We then print out the value of intercept using a formatted string. This value represents the point where our regression line intercepts the y-axis. In the next cell, we will calculate the accuracy score of our model using the score function. In this cell, we are calculating the accuracy score of our linear regression model using the score function. We pass in our testing data, x_test and y_test, which we previously split from our original data using the train_test_split function. The output of this cell is the accuracy score, which ranges from 0 to 1, with 1 being a perfect score. In the next cell, we will calculate the mean squared error of our model using the mean_squared_error function. In this cell, we import the mean_squared_error function from the sklearn.metrics library. We then use our previously created regression_model to predict the y values for our testing data, which we split from our original data earlier. We store these predicted y values in a variable called y_predict. Next, we calculate the mean squared error of our model by passing in our predicted y values, y_predict, and our actual y values from our testing data, y_test, to the mean_squared_error function. We store the result in a variable called regression_model_. Finally, we output the mean squared error value, which is a measure of how well our model fits the data. In the next cell, we will calculate the square root of this value using the math.sqrt function. In this cell, we use the math.sqrt function to calculate the square root of the mean squared error value that we calculated in the previous cell. This value is a measure of how well our linear regression model fits the data. The output of this cell is the square root of the mean squared error value, which is a very small number. In the next cell, we will use our trained linear regression model to predict the next day's stock price based on the latest open, high, low, close, and volume values. In this cell, we are inputting the latest open, high, low, close, and volume values for a stock and using our trained linear regression model to predict the next day's stock price. We do this using the predict function and passing in a list of the latest values as an argument. The output of this function is the predicted stock price for the next day, which is displayed as an array. In the next cell, we will use this predicted value to make informed decisions about buying or selling the stock. In conclusion, we have successfully performed simple linear regression for stock using scikit-learn and made predictions for the next day's stock price based on the latest open, high, low, close, and volume values. This can be a valuable tool for making informed decisions about buying or selling stocks. Thank you for watching this video walkthrough, and I hope you found it informative and engaging.